Now, in the question that we're going to do, exercise on moments, and that is exercise 8C. 8C, question 7, 8, and 9, so that we can be able to see how do you approach question to do with moments. So I'm just going to put the key areas of the question so that you can be able to see the approach in which we are going to apply. So this is exam style questions. Question number 7. Question number 7, we have a uniform beam, and this uniform beam, we have A, then we have point B. There is a string that is attached to it, a uniform beam AB of length 5 meters. So meaning from this end to this end is 5 meters. Very important to note. And then we have a point C somewhere here, which is also a string attached. So a length of 5 meters and mass of 60 kgs. Then meaning that we can have a section where the weight or the mass is going to act. And since this is a uniform beam, it means this is going from here to this mark. It has to be 2.5 meters because the weight will be acting at this given point. Then more information is provided. It's then held stationary in equilibrium by 2 vertical wires attached. These are the 2 vertical wires at point A and at point C. The tension in wire C is 4 times the tension in wire A. So meaning that if we can be able to say this is T newtons, 4 times, we are told is 4 times, so we can say 4 T, and this is T. Yeah, because the tension in wire C is 4 times that of wire A. And then there is a mass which is attached here of 40 kg, and the weight, the mass of this is 60 kg, the mass of the beam. By modeling the beam as a uniform rod and the rod has particles, calculate the tension in the wire at C. We're supposed to work out the tension in the wire at C. So in this case, we are going to use the concept of clockwise moments and anti-clockwise moments. So we can consider anti-clockwise moments as positive. So we can work out the moment about which point. We can work it about point B, and take our moments about point B in order to work out this. Yeah. So in the process of modeling this as a way of trying to work out the tension, what we need to remember is that this blank or this beam is at equilibrium. So since it's at equilibrium, we can try to fill in some of the information that we know. Number one, this distance here is going to be what? Because from this point to this point, we have said is 2.5. From this end to the other end is also 2.5. So if we check any other information that was provided here, it's held horizontally by 2 wires. So what's the length of C? CB is the one, CB is the distance that we shall be finding. So this is going to, we can call it X. And this will be 2.5 minus X. 2.5 minus X at this point. Now that we have that, we can say the beam is at equilibrium. And if the beam is at equilibrium, we can decide to take moments about point A. So take moments about A. So this is where we're going to consider our moment. So every time we are going to refer to this particular question, what you really ought to remember is that our moments are going to be taken right from A. So then we are going to work out clockwise moments and anti-clockwise moments. So another thing that you have to put into consideration or perspective is that we have to ensure that we are going to consider clockwise negative and clockwise positive. But at the same time, we can be able to use this principle that says here, when a body is at equilibrium, the resultant force in n direction is 0. So we can say sum of upward forces is equal to the sum of downward forces. So in that case, we can say T plus 4T is going to be equivalent to all the downward forces that we are having in this particular question. And now for us to be in a position to really work out this, we are going to say the upward force is this tension and this tension, but the downward force here we shall have 60 times 9.8, so that we convert the weight, plus 40 times 9.8 in that case, so that we are going to put work it out in sense that we're gonna get 5T is equals to, so if we try to work out this, we are going to get 60 times 9.8 plus 40 times 9.8. So if we work it out, we are going to get 980. Then we shall divide by 5. We shall divide by 5 here, which is going to translate to T is equals to 196. But we are in this question, we were asked to work out the tension in wire C, and wire C is tension in wire C is going to be 4 times 196. So times 4, that's going to translate to 784 Newton. That's the tension that is basically in this particular line that we are talking about. The next question that candidates were asked here, because these are just practice question, is to find the distance x, to find this distance x that we are having here. So how are we going to work out this distance x? So in order for you to work out this distance x, we are going to take moments. We can decide to take moments about B. Yeah. Now that we have the forces here, we have the force of equals to 196 Newton, and this force is equal to 784 Newton, and then we know the weight acting downwards, and we know the weight of 40 kg mass acting downwards. Then we can be able to take moments about B. So if we take moment about B, we are going to say clockwise moment is equals to the anti-clockwise moment, and in that case, clockwise moment being equals to the sum of anti-clockwise moments. What will that mean? It will mean that you have to consider each of the force with respect with the point, the turning point or the pivot. So this force here is going to give, this one will give a clockwise moment. This one is going to give clockwise moment. And then this force here will give anti-clockwise moment, but this one will not have any impact because the distance from the pivot where the force is acting is 0. So that way we are going to say clockwise moment will be the distance from A to where B is basically 5. So it will be 5 times 196 plus this one, also the distance is x, so we don't know that. Then it will mean that that distance is going to be 784x is equals to anti-clockwise moment, which is provided by the 60 kg, so which is 60 times 9.8, so that it becomes newtons. And then now the distance will be 2.5. So it would be 784 x is equals to 60 times 9.8 times 2.5, which is 1470 minus 9.6, which is 980. So x is going to be 1470 minus answer 490 divided by 784, which is going to translate to 0.625 meters. So this particular distance that we are talking about here is now equivalent to 6.25. Yeah, so that's exactly what the candidates were supposed to do. Yeah. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. And also you can check our Patreon page where you can be able to access the notes, these particular notes that I'm sharing here, in order for you to prepare well for your exam. See you in the next tutorial.